of the English language, or they might be English language learners, or just have various other challenges. And there's so many things to bring up about what happens when you talk to the computer. So if you just go to good old Google and you click on that microphone, tell me about artificial intelligence. There we go. That's what it's going to tell me. It'll give me the search results. Sometimes you get something more interesting and specific. Sometimes you just get a search result. But while you're talking, you're seeing how it's interpreting your words. So if I don't really kind of know really what, so I just want a question. Remarks from President Biden. Oh, I'm embarrassed. Really, Google? So what the computer understands and what it takes out of what you say, it's kind of hard to understand how a computer prioritizes one word over another, how it turns our words. It tries to, like in that NACLO thing that Rebecca did, it tries to figure out the words in context. You know, the word that came before it and the words you're saying now never follow each other. And so, yeah, I didn't see that coming either, Charlotte. Definitely not doing that one again. I feel betrayed. So let's hop into the Jamboard and just give that a little thought. So if you go on to number 2 and you're talking about Google, what would we want to point out to kids when we just have them talk to the computer and ask it questions and see how it takes their words? Are there some issues of equity, impact, and bias that might be involved in there? Are there some issues about algorithms and data and how computers are taking sound, which is a very human thing as we create it, and turning it into digital words, right? You got to go to the second page in the Jamboard. It's the same Jamboard. You can just switch pages up across the top here. So what are the possible problems that happen when you talk to a computer? There's an awareness that kids could have a good conversation about. Where do people use these things that you talk to? What happens if something goes wrong? If you have voice recognition on your house and you have a cold, maybe it wouldn't let you into the house. What are some other possible impacts about using voice recognition, which is so fun, age-appropriate content? Yeah, you know, that could definitely be a challenge in elementary if you use an open Google search. So you've got to make sure it's set to safe search before you go searching. And the first attempt in learning, the first time you do something, it might not work. That's a great place where you can do that. Should we have directions for best practices? Using lots of words instead of being specific about how computers need you to really be clear in your directions. They can only guess so well from what you say. So those are great takeaways for understanding computer science and how artificial intelligence in particular interprets the things that we say. And it's always good to model something bad as well as something good. Here's how it is when it works. Please find a better example though. And here's how it is when it doesn't work. So moving on, that was area number 1, right, about perception. And this is area number 3, which is about machine learning. I'm just picking these 2 because these have the best developed resources right now, although there's lots more coming out. So when you look at this idea of machine learning, it lets the computer do things without people specifically telling the computer what to do. And it does that by actually changing its model of how the information is connected and making new connections and coming to new conclusions. The larger the amount of information you can give to the computer, the better its ability to make predictions and be accurate. And then the model that the computer makes can be applied to things it's never seen before, and it can make conclusions. So if we take a look at just a few, and again, the links down at the bottom here to the entire set, there are many, many, many learning objectives and enduring understandings that come with this area of machine learning. At the youngest level, we talked a little bit about how some of these activities were a good way for kids to recognize patterns. Well, that's one of the first things we want them to do, is to recognize that because things do have patterns, it's a way that a computer can then make connections between things because it can be made to recognize those patterns. They use the example here about poisonous versus non-poisonous fish, and then For a person, if you looked at a whole bunch of pictures of poisonous versus non-poisonous plants or animals or something, what do you see as kind of a common pattern? And because we can do that in the human way, it helps us better understand a little bit how the computer does it. Although the computer does it not as weird as quantum computing, but it's pretty weird the way it makes connections between things. And then in upper elementary, we'd actually like kids to look at an example of how they learning actually happens and kind of break that process down. I think that that's a lot of fun. So to do activity, sometimes we use unplugged activities, sometimes we use things on the computer. There's some great stuff on the computer. But here's one that you can take and share that Vicki had created from the AI for Calc 12 group that has a Jamboard that has 2 empty circles and a bunch of foods on either side. And so when you click on that, it's automatically going to make a copy of it for you. And so each kid would get their own copy, and then they would be able to move the foods around and then have the chance to express, where do you see a pattern between the foods that are healthy and the foods that are not? And they intentionally skewed the data so that most of the things that are green are healthy foods. And then if you introduce something like a green Jolly Roger candy or something, which category is it probably going to go into? Well, the kids are going to say it's an unhealthy food. Yeah, but would the computer know that? What does it have more in common with? Oh, well, all the green things are over there on the left, so it would probably say it's a healthy food. Sometimes people make that same interesting logic leap. It's green, therefore it must be healthy. Oh, so let's just pull this one together one more time and look through here. So limitations of computers, age-appropriate content, very important here. Clarity of directions, how 1 or 2 words can make or break a search, and less so over time. So what might we get here on the third one? You can see all the healthy foods are green. All the unhealthy foods are either yellow, brown, or red. Coincidence? Not in this case. So what data you choose to give a computer so that it can make its own conclusions, and maybe are there some things that you can't tell much about them just by looking at them? Maybe you need other kinds of information in order to make a decision. Not everything green is healthy. Not everything red or brown is unhealthy. So color cannot be necessarily the base. Patterns don't always provide the truth. And that is like a key concept in bias and artificial intelligence, right? The historic data that we take and use as the basis for the things that we give the computer have terrible flaws in them and have been collected with all sorts of nasty errors of judgment. They allowed a AI chatbot to gather information from an informal chat on the internet, and the thing started spewing hate because that's what people post in their spare time up there, and they had to take it down because that's what it learned from the people. Maybe the information available to us isn't good information. Looking for multiple conditions, right? Not just a single feature. Natural food versus processed food, and how do you tell the difference between one and another would be a good content area conversation to have. The algorithm is actually going to have to be kind of complicated, and it has to be inclusive right from the beginning. And does everybody really even agree on what's healthy or what's unhealthy? What's fair or what's not fair? Those are some of the decisions computers are making. And are we really doing that? So that's just one fun activity. Take it away, use it. This is another really fun activity. And so Elisa's put the link there in the chat. I would love to have you try this while I talk a little bit. So it's just quickdraw.withgoogle.com. I'm sure you could just Google quick draw and it would find it. This is just a clever little fun thing, and understanding what's underneath the hood lets you have a really rich conversation with kids while they just get to play with something. And, you know, mouse skills. Yeah, I love this thing too. Mouse skills can be a little iffy depending on the age. So it can be a little frustrating depending. But how does the computer know that a snake is a snake? How does it know that it's not a ribbon? How does it know that it's not a twisty highway? Well, because it's been fed thousands, or maybe at this point, millions of different pictures of people trying to draw a snake. And so when you draw something, it has millions of examples of all the different things that it might ask you to draw. So which is yours the most like? And it's again that pattern recognition thing that's going on. Well, if all of the people who use this were in North America, they might only put in North American snakes. And if there's a very different looking kind of a snake from somewhere else, it probably wouldn't get recognized. So that's a wonderful opportunity to talk about how the experiences or the data that the computer has determine the results that it comes out with. And if you draw the same way as a whole bunch of other people draw, it's going to recognize yours. Both it tries from the moment you start, right? As soon as you start trying to draw, it's trying to guess what that is. And it keeps trying to refine its estimate. So go ahead and unmute and tell me anything that you find either interesting or challenging about doing this with kids. The data set portion is interesting. And I think it's us having that knowledge is stressful. I know, I think it is kind of stressful. We wanted an untimed version of it. Oh.
I was going to say the same thing. It is stressful, but it seems like you're trying to find fun ways to pull out that stressfulness or that continuity of understanding.
And isn't that also like this great opportunity to have those conversations about like not letting the frustration take over and figure out what is your real goal? Is your goal to win against this computer? Are you going to get any kind of recognition or prize if you get it right? No, it's okay to get it wrong. But what, because you want to get it right, you've created your own stress. But really, it's more about just seeing how's the computer responding to me? Let me do this intentionally wrong and see if I start with the feet first instead of drawing the head of an animal, will it be able to figure it out? Or if I do the tail first, is there any way it's going to recognize it? You're just kind of experimenting with this computer. You're not trying to get it right. And so I think that for this kind of thing where frustration is a factor is a really important thing, because a kid could walk away hating it, but that same kid could walk away intrigued about how that worked, even if they could only successfully draw a couple of simple lines. What's the fewest number of lines I can do to get something to where it is? And so this is the last one that we're going to kind of pull the takeaways, and you'll obviously have access to this later on if you wanted to come back with it. I don't know where my Jamboard went. Well, never mind. We won't do the takeaways for this one. I forgot to make the page. But you got some takeaways. If you haven't used it before, it's fun. You got a little spot of time to fill in. But again, framing it into what's the learning that we're trying to get out of that? It's a fun experience, but you can walk away without taking much away from it. You would be amazed at all the stuff that's coming out for AI. The funding is just there. And so ISTE has a number of unplugged activities for teaching about AI that are pretty nice. You might want to look at. TED Ed has a number of really good, and they know how to make good quality videos that really get a point across. And so can a computer talk like a human? Well, there's a test. Can a person tell whether it's a human or a computer? And they're all in that nice, 4 to 5 minute range where you can possibly keep somebody's attention. Could a robot really be creative? What a great conversation this is to have. And you better believe robots can be creative now. So we have lots of great examples. There's a little riddle problem, maybe for older kids with a math spin to it, and talking about machine learning and how AI learns. And I just felt like these were really nice bites of things to expose kids to. In addition, and look at the age level we're targeting here. Look at the size of those great big eyeballs. This little series of kids' books on all sorts of STEM related things includes lovely ones for artificial intelligence. So unplugged activities are needed. Yeah, definitely good to have the unplugged, and exploring through there. It'd be nice to have a few friends to explore through some unplugged activities together and come up with the best ones. So there are many books now and many online resources for specifically artificial intelligence that have come out just over the last 3 to 4 years since the funding has come through. This one is cute. The target audience is elementary school. It's called AI and Me. I know when he originally created it, it was free. I don't know if it's still free. I don't know if has anybody tried this one? readyai.org, AI and Me. And so it's just, a little 1 hour lesson, the 5 big ideas of AI from somebody who got together with the group in our early days. And that was a lot of fun. So if anybody peeks in there and sees if that's still free or not, I'll update my materials. Otherwise, I'll add it to the slide later. There's
Looks like you have to log in. I can't tell if it's free.
you might have to create an account now. Yeah, we all got
Yeah.
to try it out for free in the beginning, but I think they added something to it. We'll see. We'll find out. Cognimate is fascinating. So there's all these extensions that kids can use with Scratch that let it do all these extra things. And so as Scratch starts including things, they keep, I think, creating new things. So it's a kind of a place to go to see what's kind of on the horizon inside of there. A really cute video that Vicki put together. If you look at something more complicated like Cognimates and you think to yourself, how on earth would I use this with little kids? There's the video. She explains it in about 2 minutes about how you could use something like this with the youngest of kids. So, again, a nice resource. I know we only have about 10 minutes left, so I want to make sure I get to show you all the resources, then we can dig into whichever ones. Cosmo is an adorable computer, which is currently out of production. It should be coming back by the end of the spring. It's switched who's doing the manufacturing. It is a fascinating little thing. It can recognize faces. You can actually programming it to do AI activities. And they even have their own competition called WACY of kids that program the robot to do smart things. And lots of children involved in that. Very interesting. Cosmo is also a robot that is frequently considered for university programs or for high school artificial intelligence programs. Why? Because it's like Scratch, one of those easy entry, low floor, tall ceiling. And you can really dig into it and do very complex things with it, as well as quickly and easily doing very simple things with it. So fun, good and fun stuff. Coming up right now, going on this week and next, our dear Charlotte is putting up a series of videos about AI for elementary. She does an early elementary and then an upper elementary at 5 and 7 o'clock. And I think at least it's every day, it was every day last week and then next week, right? Yeah.
Correct.
So these are where the recordings are for the ones that she's already done. So she's done 5 of them, well, 10, early and upper elementary. And so they're a delight. They're, as you can see, 30 to 40 minutes long. So they're supposed to be a do it with me kind of activity. So you're supposed to go in there together and try things out. She jumps in very quickly. So it might kind of feel like an example of, oh my goodness, she's just telling me to do 5 or 6 things all at once. Well, yeah, pause the video, make sure everybody's set up. But as she's going through it, she starts to tease out these concepts about persistence and patience, about errors and being wrong and it's okay, about what's really going on under the hood. And so she doesn't like present all that at the beginning and give you the framework. She interjects it throughout the experience so that it's kind of a natural part of what's going on. It's a very, very, very nice series and a resource that should be there for time to come to use in clubs or camps or schools.
And there's 2 different levels. There's a K to 2 and a 3 to 5.
Right.
So,
And she has the K to 2 at 5 and the 3 to 5 at 7, right? Eastern time. So some of the guidelines that the group had come up with about supporting students as we get them into AI is to constantly reinforce that idea that it's not magic. It's technology that's in action here. You might not be able to see what's going on the inside, but there's equations and data that control what's happening. And that's sort of one of the main themes. The idea that kids are building these mental models about what's going on and sometimes just sketching out what it looks like is really useful in supporting kids' understanding. And then the final thing is it's really, really great for kids to actually create something. And it's so easy to do in a world like Scratch, where they have those tools in there, where it has sentiment analysis, so that when you type words in, it can try to decide, is that a happy thing you said? Is that a sad thing you said? Or is it neutral? Is that an aggressive thing, or is that a passive thing? You know, there's lots of different ways to try to get the sentiment out of our words. And that's something that's built inside there. So I talked a little bit about WACI. That's the competition that uses the Cosmo robot. And so I think I forgot to put the link in there. You'll find it if you look for WACI. This has been going on for about 3 years now, I'm going to say. There was a group out of Pittsburgh that was running the competition there with a group of local schools. But just take a quick look at the age of the students that are participating, programming the little robots to use their own artificial intelligence to adjust their programs based on the circumstances around them. And one of their favorite things to say is artificial intelligence is actually anything that a computer does that it would seem smart if a person did it, like avoiding an obstacle or figuring something out. So they're doing artificial intelligence. I don't necessarily recommend the competition. The robots are about $150 each, I think. But it's just interesting to see that that's going on. One of our biggest things here was to share the resources. So we showed you the Code 5 live webinars. Those are the ones on the YouTube channel. There is our own workshop series that meets in the evenings, and it's getting ready to start, I think, this coming Monday. We also have sessions in the summer. If these links work, I don't know if I copied them right. We would love to have you. We've had people develop lessons for kindergarten, for high school sociology, you'll see them at the end of our AI symposium, some of the lessons people made as a result of participating in this workshop. It's 2 hours a week of meeting time to get together and talk and ponder over things, and then some online videos from MindSpark and IBM about the different areas of AI and how it affects the world around us. Also, if you're looking for a free CPD credit, it is a CPD credit option if you do the create a lesson plan while you participate in the online sections. So please think about joining us.